Okay, guys, good morning. Welcome back. So we are going to continue with our session. So today is day 4 session, and today and the time. Oh, sorry. Yeah. So guys, like if you check it out in our last session, right? Like basically we created AWS account. So and we also saw the whole step of how to create it, right? So please, some of you if you have missed it, please go to that session and try to create your account. It is very important. I would humbly request everyone to have an AWS account. Right, within a couple of days, please create an AWS account because we'll start working on AWS itself, right, as of now. But slowly, gradually, we'll get into even Azure also. Azure also, I will show you how to create a new Azure accounts and how to practice in Azure Cloud. Okay, so that's what we had pretty much covered. And if you see the day 2 session, guys, we had covered some of the things, but we were looking into the deployment strategy, right? In deployment strategy, I just covered a rolling update and a blue-green deployment, right? So this is the two things which you had covered. And there are many other deployment strategies are there, like kernel deployment, recreate, and some of the other things. So let us see what is all this in today's session. And also let us see like what are the other topics I'm going to cover today. Okay. So guys, let us start our day 4 session, sorry. So we will continue with our deployment strategy only. Sometime I do mistakes while typing some spelling, so just bear with that. Okay. So guys, as I said, right, in organization, we always do the deployment, right? It means that whenever the application code is updated or it is uploaded into the some of the repositories by the developer. So what the DevOps engineer will do, he will take that code and he will try to build it. So he'll try to create a build out of it. So when you create a build out of it, what you are going to get, you're going to get a package. And finally, you have to take that package and deploy or install into some server. And there are various ways are there we saw it. Like one was with the ruling update and the second was with the blue-green deployment. So let us see what is a canary deployment actually. Right. So these are all very important because in many places, like for example, when you are learning Kubernetes, you will come across with blue-green deployment and you will come across with what is canary deployment. When it comes to the rolling upgrade is very, very common terminology which is used in almost all organizations, right? Wherever you work on DevOps and cloud, you will be hearing this word rolling update. So rolling update we have already discussed, right, in our day 2 session itself actually. So I would request you to go through that session again one more time and try to recollect what was rolling upgrade. Okay, so today we are going to start with, or we are going to understand what is canary deployment. So canary deployment is also very much common in Kubernetes environment, as well as in many other, in many other organization, we do the canary deployment also, right? But usually what happen when you are working more on Kubernetes environment, right, where you'll install Kubernetes cluster and where you do a deployment, there we use a canary deployment also. Okay, so what is this canary deployment is all about? So guys, open the MS Paint and here what happened guys, like here for example you have a server where you have an application and it is of a version. Okay, it means somebody has developed the V1 version, right? And like basically what happened, right? Like we have something like a load balancer normally, or you can, in case of Kubernetes, we call it as an SVC. So let me take a Kubernetes as a thing actually, because here in case of the application there in Kubernetes, we call it as a pod actually. So this is a pod actually, we say. Okay, don't worry about all these terminologies as of now. I'm just saying in case of a Kubernetes, we call it as a pod actually. Okay, so what is it? I said it is in the case of Kubernetes, we call it as a pod. In case of a generally, like for example, if I take a virtual machine, right? This is a virtual machine, we say, and in the virtual machine, basically what we do, virtual machine means this server actually. Virtual machine, or we can call it as a server. Server, guys, we go and deploy some application. So you need to create an environment here to deploy the application. Create an environment means whatever your application requires the software stack. or software requirement, those software will install in this virtual machine or into the server, and then we host the application. We host means we actually go and deploy or install that application, we say, right? And whenever an end user, so he's an end user, it's like you or me who sits in a laptop or who sits in desktop, he want to access this application, he has to access via with the help of a load balancer. So the request will go like this to the load balancer, and from the load balancer the request will be redirect to that sorry the request will be redirect to that specific application where it is running in that machine like this. But here in case of Kubernetes, what I'm saying means here, instead of load balancer, we have something as a SVC. We call that as a service actually. So whenever a user want to access the application which is there in the Kubernetes cluster that is in a pod, he will access via the SVC. That's what I have to understand. Right. So now coming back to here, what is a canary deployment? So we had learned about what is a blue-green deployment and all. Let us try to understand canary deployment. Now, guys, what is canary deployment says that actually, suppose if you are having one server where you are having an application of version V1. Suppose we want to upgrade this version V2. So assume that I have one more server like this, one more server with this, where what happened, right? We have an application, the same application with the upgraded version, which we call the V2. Okay. So now what will happen, right? We will have one more server where we have installed or deployed the latest V2 version, app 2 version. So somebody might ask a question, Rajesh, why don't you deploy the same application V2 into V1? So guys, when we want to upgrade the V1 to from V1 to V2 in the same server, what happened? You will see the downtime of that application, right? So it means that you have to something like you have to uninstall this V1 or you want to remove the files and everything and deploy a new version that is V2 into this. So if you're trying to overwrite that application on same server, then there'll be a downtime of the application and you cannot see the downtime in the real time environment. It means that if suppose assume that a client is accessing, if this end user is accessing a V2, V1 application or the application which is of a V1 version, and on top of it, some engineers is going on go and deploy the V2 version. So when you are deploying it, it will take some time to deploy. It will take some time to restart that application, do the clear caching, restart the application, remove some temporary file, cache file, so many things you remove it, and finally you will make that application up. So during that time, when you're doing that process, there will be downtime of that application. It means that literally that application will be down. And in the real time, guys, you cannot make that application down even for few seconds also. You cannot, have you heard any time saying that, okay, YouTube is down for 4 seconds, 5 seconds, or 10 seconds, or 1 minute? Have you heard anywhere in your lifetime? Have you ever seen that Gmail is going down or Google Drive is going down? Have you ever seen Facebook is going down? Right? So and have you seen anywhere Amazon.com applications going down? This application will never go down in the entire year. If you calculate entire year, they say that hardly that application might have gone down for 1 or 2 seconds. Even a lot of people would have not even experienced that downtime. But what I'm saying means, so you cannot afford the application to be down. Hence, what they do that if you want to upgrade the version, if you want to upgrade from V1 to V2 like this, so what time they do, right? They will take one more server or one more virtual machine. They will install the V2. And what they do, right? Basically, right? They will try to redirect from here also. They will try to from the SVC. They'll try to redirect the traffic to the this server where V2 is running. Now, this is what it happens. Now, what canary deployment say that? Canary deployment say that, sir, whenever there is a 100% traffic, suppose traffic means if the 100 user who want to access that application, 100 users who want to access that application. Now, what canary deployment say that? Okay, they will say that, okay, for the canary deployment, what we'll do, since we have both this application, V1, V2, same application, but one is a V1 and other is a version 2. Of course, version 2 is having little bit more feature compared to the V1. Right? That's what we call the V2. Now, what we say that, okay, sir, let us do one thing. Out of 100%, let me divide the traffic, means network traffic, something like 90% traffic to the V1, uh, traffic to V2, like this. So it means that, so 90% of the traffic, if there are 100 users are there who want to access the application, what this SVC do, SVC will try to forward 90% of the users traffic to V1 and only 10% of the to the V2. Or else, for example, if there are 10 users who are accessing that application, 9 users for it will be redirected to the V1 application and one will be redirected to the V2 version. Do you agree with me, guys, with this? So now,
Rajesh, we can't hear you, Rajesh. Can you?
hello, can you hear me, guys?
Yeah,
Yes, we
now
can.
it's okay.
Oh
Now it's
man,
okay,
please,
Rajesh.
guys, please, I don't know what has happened. Please, guys, whenever you don't hear it, immediately you tell me at the same instance. I don't know, there is
Okay.
some problem. How for how long you're not able to hear?
I think 1 or 2 minutes,
Oh
Rajesh. I thought
man,
my network is
no,
down.
no, no. I'm sorry,
I
sorry, sorry,
was
guys.
checking and now
Oh,
I'm.
I missed it many things, man. Many important things I was explaining. See, when I was trying to write something, you would have understood, right? Okay, Rajesh is saying something. So immediately say, man, what is this nonsense? It should not happen like this. Now, are you able to hear me?
Yeah,
Yes,
yeah,
yes.
yeah, fine.
Okay. So guys, sorry, I'll get back to again. So now in the last 2 minutes, what I told that actually, guys, now whenever what is canary deployments? Canary deployment says that you will have two versions of that application, the existing V1 version and the upgraded V2 version. Okay. So now what happened? Whenever the traffic flows, what canary deployment says that the traffic will be divided across these two versions. Now here in this case, what happened? 100% traffic when there are 100% users are there. How the what Canary deployment say that 90% of the traffic will be initially sent to the V1 only, to the older version only, or to the existing version only. Only 10% of the traffic will be sent to the V2 just to check or test or verify whether how V2 is responding, how V2 is responding, because we have to verify also, right? If you verify V2 is responding fine, if V2 is not failing, V2 there's no downtime, okay, it is responding very well, then when we get that clarity that okay, V2 is actually responding, then what happens, slowly we'll try to increase the traffic. So earlier it is, now it is 10 to 10%, now later we'll increase to 10%, 20%, 30%, 50%. Finally one time will come where we'll redirect the whole traffic to 100%. So where you are be redirecting? V2. Right, this is candidate deployment. Slowly we'll do it. So now the question comes, Rajesh, okay, fine, we understood it. How we are dividing this rule? Actually, what is this percentage? 100% means 90% initially we are sending to V1 and 10%. Who is going to decide, or how we are going to decide it? Guys, in case of Kubernetes, actually, in case of Kubernetes, we have something as a service mesh. Okay, this is nothing but Istio. So many of you, some of you might have heard about this actually, right? So in the service mesh Istio, there are two important things which we call it as a destination rule and virtual service. So with the help of these two components, or with the help of these two, what we do that, this is a service mesh. Later, guys, we'll cover more in detail in service mesh. What is it? Right now, don't ask me any questions. So with the help of a Kubernetes service mesh, what happened, right? We can set up a rule. So who is dividing the rule between 90 and 10% all? That is because in case of Kubernetes, it is service mesh or Istio we say. So there are two components. Other one is a destination role and virtual service. Because of these two, we can divide the traffic between these two versions of that application. Am I clear on this, sir? Till here? Okay. Now you said, Rajesh, earlier you used to say that, okay, I'm having one virtual machine here, virtual two machine. I'm not talking anything about Kubernetes. Forget about Kubernetes. You're just deciding, discussing about the virtual machines, like where we have app one, and in other virtual machine where we have an app two. Okay, fine. Here, instead of SVC, what we were used to call here, guys, we used to call here as a load balancer. It means that basically you will have a load balance here, right? A load balancer here, right? We'll have a load balancer here. Load balancer. What is load balancer and all, guys? We'll discuss. Okay, later. So now what the load balancer will do? Load balancer will also does the same thing. It will also try to distribute the traffic Okay, so some of the traffic will be sent to V1 and some traffic will be sent to the V1. Like this, it does it in case of a normally load balancer and all. And here what happened, the end user or the user will be sitting here. So he will access that application, means he'll send a request to the load balancer, and through the load balancer traffic flows. Right. So in case of what are the different load balancer we have? So guys, in the real time, like we have a lot of load balancer, but usually what happened, right? We have a load balancer which are more appropriately used in the organization is Apache and Nginx. These are the two important load balancers we are having. Actually, again, apart from this, we have HA proxy. I will discuss all these things in our upcoming class. Okay. So network load balancer, application load balancer, Nginx, Apache server. There are so many load balancers are available, right? Right. FI load balancer is there. These are many load balancers are available, but we'll be predominantly discussing more on Apache and Nginx and HA proxy. Okay, and these are the most highly used load balancers in the organization. So load balancer will also can divide this traffics like 100%. If 100 users are accessing this load balancer, no, it can redirect the traffic. Like 90 users, it will send it here, or 10 users will send to V2. Like how again it will do that? Here, what happened for each and every load balancer, like Apache, Nginx, or HA proxy, right? It has an algorithm actually. It has an algorithm. It has an algorithm where you can divide the traffic actually, right? So based on the weight based, actually, you can send a traffic actually. You can divide the traffic between these two versions of that applications. So what is this algorithms? What are these wave based or rule based or this and all are different types of configuration settings what we do into these load balancers, right? This is in case of a normal server we do, and this is in case of a Kubernetes environment where you will have something as an SVC, you have something as a pod, right? So guys, I hope that you understood this, right? So canary deployment, what you will see that Rajesh in canary deployment, sorry, I will write it here. Canary deployment, what you have observed, you will say that Rajesh, there has to be there has to be two servers at least, right? Where in one server we have V1 application deployed, V1 is existing, and in another server, in the second server, server 2, V2 exist, right? And what that is a minimum thing, right? You might ask, Rajesh, is it only one server where V1 are there? No, no, guys, it's not like that. In the real time, you have V1 like this, one more machine where V1 application is installed, the same version here, V1 application installed. You will be having n number of servers of the same version, V1, V2. Similarly, here also, you have one server where V2 is there. It's not only one server, you have one more server, you can have multiple server based on your requirement, where you are having an app V2 here like this. Like this. So what I'm trying to tell here that in case of a kernel deployment, there is no downtime of the application, and minimum two servers will be there. This server and this server. But here, as I said, you can have more than one also, right? In case of version 1, you have 3. In case of version 2, we have 3. Okay, that is also fine. No problem, right? And in case of the dividing the traffic, in case of Kubernetes, that is taken care by service mesh istio. In case of a normally load balancer in turn will take care of that. So you have to configure so that you can divide the traffic in terms of percentage. Like 90% should go to V1 and only 10% should go to V2. Like that, you can divide the traffic in by configuring in the load balancer. This and all, slowly we will learn, don't worry. So here what happened that we follow something like a ratio, we say. Follow something like a ratio. Same thing guys, 9:1, something. 9:2 means out of 10 users, 9 number of users will be sent to V1 and 1% or one user will be sent to the V2 like that. Okay, good. Now, what are the other things we have next? We'll quickly go complete guys because this will take time. This is taking time actually. Recreate deployment actually. So recreate deployment is quite simple, but right, quite simple. I'll take one more MS screen to explain it. So these are all very important, guys. You should have all these things in your back of your mind, right? So what recreate says that actually recreate deployment says. So in case of recreate, assume that you are having uh, a server where we are having an application which is of a V1. right? And similarly, like we have an SVC here. This is SVC. In case of Kubernetes, I'm talking about SVC, service we say. And here what happened that you are having a user here. This is the user. Now the thing is that, okay, this is a single user. He want to access the application means he will send a request to the SVC in case of a Kubernetes. And from the SVC, the request will go to this application. Okay, fine. What is meant by recreate means? Recreate means what we say that basically, right? So Rajesh, I'm having a V1. After some time, I'll come up with a V2. In case of recreate, what we'll do that? We will try to make this application down. We'll try to make this application down. We'll try to make this application down. What is V1? And then try to install the V2 here, and make the application up. So we'll make the V1 down, version 1 down, and we will try to install it, and we'll try to make the V2 up like this. We'll try to deploy new deployment of V2 and make the server up. Right? This is what. So it means that Rajesh, like we will have one more, we will have the same server or one more will be there, same server where now the application is V2. So now what happened, right? This SVC or load balancer, whatever, it starts sending a traffic to this V2 version. So now what is the thing with what you're seeing it? So guys, you are seeing that here there is a downtime of that application, right? Downtime of the application is there in the recreate deployment, right? In the recreate, downtime of the application is there. It means that you will see the downtime, right? And what happened, right? A recreate deployment cannot be used in production environment. Cannot be used in production. Obviously, right? In production, you cannot see the downtime of the application, right? Recreate deployment. Sorry, recreate deployment is always used, or it is always implemented in lower environments. Like what are the lower environments? Dev environment, QA environment, like this. So there, right, it is okay, fine for me in dev or QA. If the application is down, that doesn't really matter for me. Okay, but you are upgrading that application from V2 to V1 to V2. But downtime is okay for me because I'm not really doing any kind of a testing, or my application is not really provided to any end customer, right, or any end user. So I'm okay with that. So that's what this deployment is always used under the dev environment in the QA environment. Right? In production, it is not used at all. Am I clear, sir? Okay, good. So any questions so far, guys? Okay. There is one more thing, was the A/B testing, which is also quite interesting. So many organizations, they use it actually. So in A/B testing, what they do, right? So what they do, right? They will have a multiple version of the same application, right? Say, for example, you have an here like this you are having. So here you are having a V1 app V1 and app V2 and app V3. So it means that you're having three different versions of the same applications. You might ask the question, Rajesh, what exactly this three version is? What is it? Something you can understand the feature, guys. Say, for example, if your application, some application is having some menu actually, right? Menu is there. Okay, this is one version. But later what happened, right? You will try to improvise that version. In the menu, you will add one more sub menu. This will be called as a V2 version. This will be called as a V2 version. This is called as a V1 version. Something like this. Again, what you say, Rajesh, again in the V3, I'll be adding some more things. So what I will do, earlier, whatever the menu had, which you added the sub menu, here what happened, right? You have added some more feature, something like scrolling or some button you have added. So this is something like a V2, V3, sorry. So something like whenever you are enhancing that application, right? The feature wise everything, I'm just giving a small example here, but there are many features will be added always in the real time. So you will tend to give an up versions actually, V1, V2, V3, V4, V5, or in many organizations what they do, V1.1, V1.2, V1.3, V1.4. After V1.9, they will give V2.0, V2.1, V2.2, like that. They'll be keep increase the version numbers. Even that decibel number also they'll be increasing. Like for example, V1.1, 1.2, 1.3. So you might ask Rajesh, what is the difference between 1.1 and 1.2? It's a minor difference, man. What's the difference between 1.2 to 1. It's a minor difference. So there will be a minor difference, but they'll be keep incrementing the decimal value just to show that okay, we are upgrading that version. Which means that there will be a changes in the from the previous version to the present version. Like that. That's the reason what happened. The developer like they'll be keep giving it. So what I'm trying to tell that here we are having three of the same application with slight new features. You are having three versions: V1, V2, V3. So what you we do basically, right? In case of a Kubernetes, basically you know that Rajesh, we are having SVC service, or in case normally we call it a load balancer, right? Right. Now, what we say that basically that we say that okay, Rajesh, I will implement the Istio here, service mesh Istio, service mesh Istio in case of Kubernetes, where like we will have a we'll be dividing the traffic, right? We'll be dividing the traffic with what method, guys? With what components based on this two? What is it? You could see the destination rule and service, virtual service. So destination rule and virtual service actually. With the help of these two features, we are going to divide the traffic actually. So what we said basically, we say that okay, Rajesh, what we do that we will divide the traffic between 4 is to something like 3 is to 3. So if there are some 10 requests are coming in, 4 will be redirected. 4 requests will be redirected to the V1, 3 requests will be redirected to the V2, and 3 requests will be redirected to the V3. Like this we do it. 4 is to 3 is to 1 initially. Now, what we see that V3 version, which is the application version, which is responding very well to the end customer, and all the features, whatever it is having, right, it is perfectly working fine. So now what happens? Slowly, we'll try to increase this traffic from 3 to 4, 5, 6, 7, and finally we will say that what are all the requests which are coming in the near future by the end user, right? 100% traffics are coming. All the 100% traffic will be related only to the V3 only. So because we tested, verify, everything is working fine. V3 is well responding very well. All 100% traffic will be redirected here only. Right? So this is also interesting here. So it looks like a canary deployment for you, but in case of a canary deployment, what is the difference? We see that Rajesh, canary deployment, minimum we have V1, two servers we are having with two versions, whereas in case of A/B testing, this is A/B testing, we are having a multiple versions of that application. And we are having more than 3 instances or 2 instances, right? We are having V1, V2, V3 here. And with the help of some kind of a ratio, we uh, divide the traffic across it. And finally, we concluded, okay, this V2, V3 is the one which is actually responding fine very well. That's the reason what happened. Whatever the traffic which will come in the near future, like 100 people are connecting, all 100 traffic will go to the V3 only. So this is something, guys, which is very much interesting. AB. So we do an AB testing. Okay, fine. What are the other thing we have? There is something as a shadow. Basically, we call this as a shadow testing. Okay. Now, what we do basically in case of a shadow. So basically, again, the same thing where we are having a server. We are having the V1 version, application V1 version. Okay. And also like what happened, we are having the V2 version application in one more server actually. Now what happened here, guys, we are having an SVC service here. Okay. And here we are having an end user. Okay. So now what happened, right? Basically, so you know that whenever the end user, he want to access his application, what do he sends a request to the service SVC, and through the SVC, what happened? The request will go to your version V1, or it will go to this application. Now, what shadow says basically, guys, as the name says shadow, shadow means something which is not true, right? So what shadow says that shadow testing, what the shadow testing says that we are already having a V2 version also in some other server. whatever the traffic which you're sending, suppose assume that there are some four users are accessing that application, all four requests will go to the same V1 version. But what the shadow will say that, okay, let me send four traffic user to the V2 also. But this is what happened. These are all the what happened. We call this is a mirrored uh, mirrored traffic actually. Mirror traffic, it's not 100% true. It's just a mirror traffic. So whatever the request we are sending, if 100 requests are going to V1, even the 100 requests will go to the V2 also, but it is a mirrored one. It means that it is a false one. So what happened right here? These are nothing but these are the like what you say that these are the real inputs given to the V2. And what we do once, as soon as the traffic goes to the V2, we will check the response of V2, how the V2 is responding to all those mirror traffic. If the response is good, V2 is good actually. If V2 is good, if the response is good, right? If we understand, okay, that the application is working fine. But what happened, right? See, usually what happened, whenever a user request for any application, what happened? The request will go to the service and the service will go to the V1. And finally, what will do that V1 application will receive that, will receive it. And finally, what happened? The V1 will application will respond also. It will respond also. Respond means it will respond to the end user like this. Okay, this is what you're requesting, or this was the okay, user, you are requesting this one. Okay, please take this response or please take this output like this. So whenever guys, when 100 users are accessing the application, the 100 response will come through the application. But here in case what happened, in case of a shadow, it is receiving that request, it is processing the request, but there is no response. There is no response. It doesn't respond it. It doesn't respond for any request. So in case of shadow, V2 app receives the request, receives the mirror request, but doesn't respond but it respond to the end client. Why it doesn't respond? That is how they have made it. Make sure that it doesn't respond, because if it starts responding, the user he'll get confused who is actually sending a respond request, right? So what happened? It will never ever try to respond to it. So in this way, what happened? User will know that how this V2 is respond, how this V2 is working. If the V2 is working fine, it accepts all the requests and it is getting processed, but it is not responding. That is fine for me. Then we conclude saying that the V2 application is working fine. Finally, what happened, right? We will try to send the real traffic to the V2. Now then we will stop sending any traffic to the V1. Later we'll start sending only to the V2. This is something like a shadow testing we say. Am I clear, sir? So I hope that guys you understood this whole stuff actually. Right? Okay, guys, that's all about the deployment. If there is any other things which is there, guys, I'll try to cover it. Okay. Okay, so this much is fine, guys, for us. Okay, now what else we have to do, guys? Like I have to show the workflow. Yeah, I'll be showing it, but before that, I have to even explain about some concept of servers and so many things. Okay, I will do it, but let us do one thing. Let us start with something on Linux, guys. So, okay, guys, how our action plan means how we are going to proceed with this course actually. Okay, so I will take 2 to 3 more sessions, only basics actually. I'm going to cover all basics aspect I'm going to cover. Okay. And I will also have to cover some basic networking. I'll do it in between all these things. Okay. You can expect some 4 to 5 sessions on basics of networking. Then what happened? We will be starting our Linux actually. So as I know that could anyone like could you please respond to me like how good you are in Linux? If suppose somebody is already working on Linux, they have an hands-on. So if they know at least some command line and everything, and they know the Linux environment, that is also sufficient for me. I don't have any problem with only basics of Linux is also fine. Okay, if suppose somebody is very new to Linux, they don't know anything on Linux, I would request that you please put some effort initially in learning Linux, because learning Linux is something like you need to learn the Linux environment. That is one thing. And also like how to create a Linux server, how to create Linux server. Okay. some general information on some general info on Linux operating system, right? You need to learn about, you need to understand about the shell, right? What is a shell actually, and then like how to execute any commands, and the different what and the different commands available. So how many commands are there? Like some, there are hundreds of commands are there. 100 means I would say thousands of commands, but we'll not be doing everything in our class, right? Basically, whenever you want to become something little bit good in Linux, actually, at least some, I would say that at least some 40 to 50 commands should be there in your tip of your hands, so that you'll be able to comfortably work in a Linux operating system. So Linux, guys, Linux is very, very important because all our DevOps tools or whatever we do in our DevOps and cloud activity, 90% of the organizations, we do all the things with the help of a Linux operating system itself. Without Linux, you cannot survive in DevOps and cloud. So if suppose somebody have not worked on Linux, or you're having some problem, you feel like Linux is difficult. No, guys, Linux is very simple. It's very easy. It's only that how much time you give. Initially, you have to put a lot of time in learning Linux. Later, you'll become very good in that. So I would say that if you start working from today onwards, maybe in another 15-20 days, you'll become comfortable with Linux. So Linux is very important. We will cover Linux slowly one by one, but I would again request that you put more effort from your end also. I'll also put my effort to make you understand. You also put your effort to learn more and more. So what we are going to do today, guys, we will be learning a very, very basic, simple concept of Linux operating system. Okay, we'll also create one more time the Linux server, and also we will set up the Linux server, and also we will discuss about some of the aspect of what is user space, what is kernel space, what is a shell. Some few basic thing I will cover today. I will not be able to complete today itself. I will not be even covering more also, because explaining more and more thing might it might lead to confusion. So I'll slowly cover, but once I started taking Linux in some full-fledged way, like after 2-3 sessions, I would speed up my like explanation. I would speed up my the the teaching speed and all that, so that you should able to sync with me. So what I would request from now onwards, that always, guys, please first have a AWS account. That is first important thing. Second is that actually whenever there's a lab access comes, you need to create the servers. You need to create a server, and you need to log into the server, and you need to do some basic commands. You need to execute. You verify that everything is working fine. Once you're done with that, what are the rest remaining activities there? Like for example, you want to do some labs, you want to execute some command, you want to write some scripts, you want to configure some server, you want to configure some other networking components or networking thing. You can do anything in Linux operating system. So first, you should be very familiar with that. Okay, you should have basic understanding. You should at least have a minimum basic understanding about how to create the machine in AWS or Azure, how to log into that machine, what is the command to log in, what is the command we use it. So many things we have to know, guys, initially at the very initial stage, to make sure that we are comfortable with Linux. And I will tell you one thing, guys. Telling you from my experience, complete experience. The guy who learns Linux very well at the very initial stage, it means that suppose you are very new to Linux and you don't know anything, but you have an intel to learn Linux and you're slowly learning. I'm telling you, guys, the day will come where you'll become little expert in Linux. Little means somewhat you are very good at Linux. After some time, what happened that when you dig more and more, you will be learning in detail about the Linux operating system and the server level, networking level, and many other stack level you will be learning on Linux. Once you become that level where you will be learning in a very in detail, I will tell you, guys, you will become master in DevOps and cloud. Because the key to learn DevOps and cloud is Linux itself. I have seen that a lot of people know Linux very well. They have a very good troubleshooting skills, and also they have slowly learned DevOps also along with that. Actually, one of the example is me only. I am the fellow who know Linux very well, but I learned the DevOps and cloud very quickly because I was very good at Linux actually, right? So that's the key, guys. So please don't shy away from learning. That is one thing. Don't think that, sir, it is too difficult or too much, or it's very headache. Yeah, it is initially, it will be headache only, because you are learning so many things. But once you start learning yourself, once you start putting effort, guys, always there have to be effort from your end also. Please put at least some 30 or 40% effort initially. Slowly, gradually, when you give more and more time, definitely it will increase your taste in understanding Linux. And once you work on it, once you work the command, once you execute many things, definitely it'll boost your confidence. So I need that thing from you, all of you, that you should be very much interested in learning Linux. if you're not completely aware of. Suppose some of you have already worked in your organization, they know how to log into the server and all. They're already doing some work means, yeah, they are aware of it. Okay, for them, there's no problem to learn. Of course, they will be learning more and more also. I'm saying, okay, right? They would have only using Linux only for some base level. But what we are going to do in the class means we are going to cover some in detail things so that we all are aware of. We'll get to know about how Linux actually works and how internally Linux also it works. Everything we will try to learn in a slow pace actually. Is it fine, guys? So, guys, before I get into the Linux, let me know how many people know Linux actually, and how many people doesn't know Linux at all in our group actually. I can take the name also, or else if you are feeling, you can even type in a. You can send him a message so that I will understand like what is how many number of participants know Linux very well, or how many number of participants doesn't know at all. So if you and one good thing is that, guys, if suppose somebody said, Sir Rajesh, I doesn't know anything on Linux at all. I've never worked on it. Yeah, I have to learn. So guys, I would say that you are the best. You can learn very fast. So some people say that no, sir, I know very well Linux and all. Like later they claim they know. Rajesh, your voice is breaking. Okay, basic I'm aware of. Very good, Rajiv. I know very basic. Pankaj also. I know basics of Linux. Okay, myself. Okay, basic. Yeah, it's fine, sir. Basic knowledge. I am good at because I'll be more happy if you know Linux basics also, because whatever I teach, I think you'll be able to grasp very well. Suppose somebody say that I don't know anything on Linux, okay, that is also fine. I don't have any problem with that. But if suppose somebody has some basic knowledge, I would say that okay, this would be quite interesting to understand and to learn it actually. Okay. So guys, fine. So let us try to learn the journey to learn on Linux. Journey to learn Linux. Okay. Of course, what happened, guys? I will tell you one thing. Yeah, yeah, Naveen. Thank you, Naveen. Yeah. So Naveen knows very well. He said, I mean, knows him since he has referred some previous videos of mine. Fine, good. So, guys, one more thing, like what happened means when you are learning Linux, actually, uh, I will use some terminologies. Initially, you might not really understanding certain things. No problem. I'll be keep repeating the same thing again over the period of time, so that you will be aware of that concept, and also you will know like how exactly whatever I'm saying, right, how it is implemented in the real time. All such things you will learn, guys. So don't worry about that. Certain things at the initial stage you might not grasp everything. Right? Slowly it happens actually. Okay. Now, guys, you might have heard, you know that we have heard something was the Unix operating system. You know, in 1970s or 1975, this Unix operating system came into the world actually, right? It was designed by Dennis Ritchie and Ken Thompson. These are two people who designed this Unix operating system. A lot of people say that, sir, the Unix operating system is like a black screen. Yeah, of course, it's a black screen. It means that actually you will get to one terminal actually, something like a terminal where you can go and execute some commands. Some people might have a question, Rajesh, what is a command actually? So guys, command is something like it is an executable file. For example, you say that, Rajesh, I want to open gmail.com. How do you do that in Windows? I'll just say that go and open any browser, man, google.com or personal edge. Okay. I'll do a double click. When I do a double click, it has launched the web page. This is the Google page. Now, as part of this, what you did initially, you have been told that go and double click onto that icon. So when you're going and doing a double click like this, guys, basically you are running an application. So it means that when you're doing a double click on it, you are actually passing some command. You're actually executing some command or passing some command. As part of an execution of that command, this web page is loaded like this. So command is nothing but it is an executable file. So Rajesh, do you think that these are all executable files? Yes, sir. These are shortcuts, executable path to the executable itself actually. So these are shortcuts we call shortcuts or soft link we say, which are path to the executable file. When you're actually doing a deploy, when you actually double click on Google Chrome, it is in turn calling google.exe file. So when I do a double click, double click on Google, what is it? Sorry, what is it? Google Chrome. Yeah. Where is it, man? Yeah. Google Chrome icon, actually it is intern executing the file Google Chrome .exe. It is actually executing this file. So Rajesh, what do you mean by command means? Command is something like you are actually executing a program, is called as a command. So there's already a program written, you just run a command to execute that program, we say. Right? This is in a very, very generic term, I'm saying it. Very, very generic. Like for example, this is my Windows, guys. Whenever you want to open a terminal, actually, what you can do, you can go to here, menu, and you can just type terminal. When you type the terminal and when you do a click here, right, it will open this terminal. This is your Windows terminal, or you call it a PowerShell prompt. So here what happened, whenever I want to execute any command in Windows terminal, I just execute some command. For example, execute a dir command. See, it will try to give me some output. So when I execute any command, as part of executing a command or a file, it actually gives you the output. And this is what we are interested. So as soon as I execute some command, whatever the output I'm getting now, I am interested more on this output actually. I'm not really bothered about how this command is executing, who is executing, all those things I don't need it, man. When I execute certain things, okay, I need to get some output. This is what at the end we all we all are dependent upon. It means that we depend upon the output. We are not really worried about how it is executing. Of course, when you're executing the command, of course, obviously your operating system, here in this case, in our case, it is Windows operating system. It is taking care. When in case of a Linux, when you're executing any command, it'll the Linux operating system will take care of doing all those activity. We need not to really worry what internet is happening, but I'm getting an output. I'm happy with the output. This is what I need, man. That's how you implement the commands. So command will make your life easy. When you execute any task, whenever you want to execute any task or application, you will be building or writing a command for that. When you run that command, that application will get executed. That's all. Am I clear, sir? Any questions, sir, for on this command? So now Krishna might ask me, Rajesh, whatever the operation I'm doing here in Windows, Rajesh, you are going and you are just doing click on this folder. It is opening something, right? When I'm clicking on the download, it is opening something. Or if I'm going to the PC, okay, it is showing me some drive. I'll click on it or it will take me. So if I click here, it will take me here somewhere. If I'm click, so Rajesh, you're doing so many operations GUI graphically. Does it is actually in the back end? Is it executing a command? Yes, sir, it is executing a command. So it means that in Windows, forget about Linux. In Windows, whatever the user does, all internal command is getting executed, man. So Rajesh, is it means that when I'm doing some GUI operation, GUI means graphical user interface. Whenever I'm doing something, is intern in the backend, a command is actually getting executed? Yes, sir, the command is actually getting executed. Okay. So what that command will do? Command will do its operation. Okay. What operation it will do? So you say that, Rajesh, I will go and I'll try to click into this folder like this. I'm going to click in this folder. See, it is opening it is opening and it is showing, it is displaying what is the content this folder has. Similarly, like this, if you go and if you click on it here, so what it is doing, it is showing the operation where it has executed that command, but in turn that command, what it doing means it is showing you the output of this, what this folder exists, what this folder contain. This is what I needed. It means that at the end of the day, some command is being executed. Okay, fine, sir. I got it now. Now, so what I'm trying to tell guys, in when it comes to Unix or when it comes to Linux, right? So how we were running any task, anything or any command or sorry, any application, everything, we are running any application or any task, anything with help of a commands only in case of a Unix. So Unix is not, but we are actually executing some command. Where we are executing this command? In some terminal. Okay. Rajesh, this is a Windows terminal, right? Correct. This is a Windows terminal, which is nothing but the PowerShell terminal. Okay. PowerShell is a terminal which is used in Windows. PowerShell is a terminal in Windows with which we can run any Windows commands. Similarly, what happened, right? There is something like a bash is a terminal in Linux with which we can run any command, any Linux commands. Okay, Rajesh, it means that there is some like a terminal will be there, which is called as a bash. Yeah, through that only you can execute some commands in Linux. Yes, sir. Bash is a main shell, we say. It's a main shell, or it's a terminal also, we say, through which we execute any commands. What is this bash? We will come slowly now, guys. Don't worry. But I'm just telling that there is a bash shell is there, where through the bash shell we get a bash terminal. With the help of a bash terminal, we can execute any of the commands. Similarly, in case of Windows, there is a Windows terminal is there. With the help of a Windows terminal, you can execute any of the Windows commands. So Rajesh, does the PowerShell in case of Windows and the Bash shell will help you to execute the command, any command? Yes, it will help you to execute that command. That is the main objective of these shells, like either Bash shell or else either PowerShell, that it will help or it will create an environment to execute any commands. So it will create an environment to execute any commands. Am I clear, sir? Till here? Yeah, that and all we'll see, Satish. Yeah, I will let you know. Don't worry. So till here, guys, whatever I said, please let me know if you have any doubts. हिमांशु, डिड यू अंडरस्टूड? भैया समझ में आया आपको क्या बोल रहा हूँ मैं?
Yes, sir, I understood.
कमांड मतलब क्या, जो कुछ आप ऑपरेशन करोगे उसके पीछे कमांड एग्जीक्यूट होता है भाई.
Yes, sir.
वो कमांड ही आपको एग्जीक्यूट, वो कमांड ही आपका टास्क रन करवाता है. जैसे कोई भी मेरा एप्लीकेशन लॉन्च किया, रन किया, कौन कर रहा है? वो कमांड ही कर रहा है बस. कमांड के अलावा आप सर, आप बिना कमांड के कोई एग्जीक्यूट कर सकते हैं? नहीं सर, बिना कमांड के आप कोई कमांड, कोई आप टास्क रन ही नहीं कर सकते. तो इन्होंने ऐसे डिजाइन किया है भाई, सब चीज के लिए कमांड कर दिया है. ठीक है, ये कमांड रन कर सके, ये कमांड रन करने से ये आउटपुट मिलेगा, ये कमांड रन करने से ये आउटपुट मिलेगा. इसलिए तो इन्होंने इतने सारे कमांड्स डिजाइन किए हैं. अगर ये सोचो कि कमांड्स ही ना होते भाई, सब कुछ नहीं होता, तो इट वुड बीन वेरी डिफिकल्ट. मतलब क्या है, हर चीज के लिए उन लोगों को क्या एक रूटीन जैसा बनाना पड़ता था. बट क्या है, कमांड्स विल मेक लाइफ वेरी इजियर. क्योंकि एंड यूजर को ना फाइनली हमें ही तो चाहिए ना, वी हैव टू एग्जीक्यूट इट, राइट. तो हमें ही कुछ ना कुछ करना पड़ेगा सिस्टम में. तो हमें अगर कमांड दे देता हूँ, उस विद हेल्प ऑफ दैट, या आई कैन अचीव वट एवर द टास्क आई रिक्वायर्ड, और वट एवर द आउटपुट और वट एवर द टास्क इज रिक्वायर्ड, राइट. मैं रन कर सकता हूँ विद द कमांड, विद द कमांड एक्चुअली. ओके, ठीक
Yes,
है
sir.
भाई, वेरी गुड. या, सो नाउ, so पहले Unix था भाई. When earlier Unix was the operating system which was available in the market. Unix has a lot of different platforms. I will not be discussing all those things as of now, right? So, but later we will see it actually. There are different platforms were there, and Unix was very much used operating system across the organization. But what happened slowly later, after some time, like in 1990s, what happened, right? A Linux operating system was evolved actually. And who designed the Linux operating system, guys? A person by name Linus Torvalds. Linus. Linus Torvalds is a guy who designed this Linux operating system. He designed. Okay, and an official, can say that official production environment, very, very stable Linux version was released. Stable Linux version was released to the market in 1992. In 1992, right? The 1992, and the first version of Linux released was, what is it? 1.0.0. This is the version which was released. Okay. Now the question comes, Rajesh, when already Unix was there, why there was a thrive to get a new operating system which is called as a Linux, which is more or less same thing like a Unix. Why a new operating system came into the market when already Unix was there? That is the question. So that's a very good question. So guys, Unix what is a proprietary based operating system. It means that it will never give any kind of a license to anyone or to any company, right? So the source codes are not given. How the Unix operating system is designed, okay, how internet works, nobody used to know that actually. Okay, even many operating systems, even today also, even Windows also, people doesn't know internally how it works and all, right? Uh, like Unix also is such operating system. But what happened? There was a thrive that okay, somebody has to explain us okay how Unix operating system works. So, but there was nobody to tell because there was not much information available in the market about the Unix. So that's the reason what happened. Slowly, what happened, right? There is an organization known as a Free Software Organization. Free Software Organization. Free Fast Software Solution or FSF. Few, what is it? Free Software Foundation, sorry, not organization, foundation. So this was an organization which was formed. Guys, it is little bit theoretical. Don't worry as of now. I'm just no, I'm just joining all the dots so that you will understand it. So there's an organization, the Free Software Foundation. This was an organization, guys, where what they said that they said okay, whatever we develop today, whoever is interested, they can put that code under the Free Software Foundation. It is freely available for anyone. Right, anybody can download that free version tool. Anybody can upload it or during modification or after the modification, right? You can put back the same thing into the Free Software Foundation. So why they did? Because at the time Unix was not free, it was a proprietary. Windows was also proprietary. Nobody is to understand like how this operating system works. So that's the reason this Free Software Foundation was started by a person by name Richard Stallman. He's a guy who started this Free Software Foundation. Now what happened, guys? This fellow has written a lot of tools. He is having his own GCC compiler tool. GCC compiler was developed, designed by completely by Richard Stallman. He had given a complete to Free Software Foundation so that it is freely available for anyone. Anyone can go and approach and anyone can download the code from the Free Software Foundation. So it was a free of cost. The whole software is free of cost. So like that, what happened, right? Many other softwares were developed and they were all put under the Free Software Foundation. Now, what happened? This Linus Torvalds, who was designing the Linux operating system, right? This person, right? He was very much impressed with the Free Software Foundation. He said that whatever I develop tomorrow, I'm going to put under the Free Software Foundation so that it is freely available for everyone. So that's the reason, guys. Linux, when the Linux was put into it, that's the reason what happened. Linus Torvalds, when he was designing the Linux operating system, after completing Linux operating system, everything, he had put the whole code in the under the Free Software Foundation. So Linux now become a part of Free Software Foundation. Part of Free Software Foundation. It become a part. It means the Linux become an open source. So we use the word as open source. Right? Who actually coined this word? This word open source was coined by a person by Richard Stallman. He is the same person who coined that word, naming convention as open source. He coined the name open source. Sorry, open source. So what is by open source? Open source is something which is freely available in the market, guys. You will not give any kind of a licensing cost for it. It doesn't involve any kind of a licensing cost. And also there is a lot of creativity in doing a lot of modification to that code. So nobody will come and ask, why did you modify this code? Why not? Because it's your own liberty they have given that, okay, you can take that code and you can modify based on requirement. So once you develop certain things in the using the Free Software Foundation, once you worked everything, now you have tested, verified everything. Now, if you feel like, okay, I need to contribute my code under the Free Software Foundation, you can come back and you can contribute your code actually. So like that, what happened here in the real time, guys, particularly when it comes to DevOps and cloud, right? Company itself will tell all the employees that please always use open source tools. No, don't use any proprietary tools. Like that, they will say. Initially, they will say like that. So whenever you're working on any project, right, you have to give them a cheapest solution by using the open source tool, not like paid tool and all, should not use it. So if any company is using a lot of paid tools in DevOps work and everything, right, in the cloud work and all, so that company, it's not like it survived. It is something like they will start struggling in the near future when it comes to licensing because they have to pay a hefty amount. Every month paying hefty amount, right, as a licensing, it will be a burden for the company. If they were already using some open source tools, right, and their work is done, then that open source tool is very good option for them. So that's the reason even today also, guys, whichever company wherever you work as a DevOps and cloud engineer, they will say, okay, man, give us best solution, but with only through the free version tool only, with an open source tool only. Don't use any kind of a paid tools and all. Right? When it comes to the orchestration, all companies go with the Kubernetes environment because Kubernetes is very good. But suppose somebody says that, Rajesh, I will go with the OpenShift Red Hat. Yeah, you can go with, but it will cost you because it is a licensing cost. Got it, guys? So I hope you understood it, right? So now, so Linux is a free version. Linux is freeware. It's a free version. We call it freeware. Why we call it freeware? Because there is no licensing. There is no license cost. Okay, it means that you not to pay any licensing cost for that operating system. Now you might ask, Rajesh, what about Windows? What about there are many other Linux are there uh, which are mm, not freeware. It's basically you have to pay the money. Hello, guys, are you hearing? Because
Yes,
I'm
Rajesh.
I'm only talking. That's what. So, guys,
Yeah.
what happened, right? All the tools are open. Many of the tools are open source tools. So you might ask a question then, Rajesh, like if all are open source, then how the company is making a money? So, guys, company is making a money because they are providing a service for it. Suppose if I use Linux, so if Linux is free, how it will benefit my company? Yeah, because when you are working on Linux, you can develop all the products on Linux only, right? And you can sell the product. You can sell the product, right? Right. Suppose some company will take a service from you. You will be giving service. So you will be giving a service money for it. Though even there also they're using Linux, but that's fine. But you're giving all the solution to them in the Linux itself. Right. So you will be earning money from the open source project. It's not like that you won't earn money. You'll be earning a lot only through service only. Only through service because that's a freeware, right? Anyone can download and anyone can install it. Right? But how I can make a money from it? Yeah, you can make more money by providing a service on that actually. Right. That is what the trick, and that's what all the people adopt it. They will use the open source version because they can, you know, they can reduce the cost for the company in the cost to the project, as well as give a lot of services to the end customer so that they can generate the revenue from the customer actually. That's all. So guys, there are more things to say about that, but I feel like this much is sufficient as of now. Okay, I need not to drag much more in this discussion. Okay, guys. Fine, guys. Okay. Now, so Rajesh, fine. So Linux, you said that it is an operating system, right? Yes, it's an operating system. Now the question comes, guys, what is an operating system? Basically, we call it an OS, right? So we say always in our day-to-day activity, we say our Windows 9, Windows 10, Windows 11, Windows 12, right? Windows 9, Windows 10, Windows 11, Windows 12, all Windows. We call it as a Windows operating system like that, right? Similarly, Linux, we call it as a Linux operating system. If we call it just in a general term, we call it a Linux OS. Similarly, we say the Mac OS, right? There are many other OSs are there in the market, right? So for anything, whatever we call it as an OS actually. But what is an OS actually? What is OS does? So guys, what the OS does basically, OS, see, whenever an end user, he want to communicate to the system or he want to communicate to the hardware, he can communicate with the hardware with the help of an operating system itself. So for example, here, I know, guys, this is more like a theoretical at the initial, but don't worry. As we get into practicals, we will learn more and more. So this is the user, guys. He's an end user, like me, who's sitting in the laptop. End user. If I want to interact with the system, see, whenever you use the word system, means it means that it is a machine or it's a server, we say, or it's a hardware. So whenever I interact with the server, all right, whenever I interact with the machine or whenever I interact with the hardware, right? So it means that as an end user, I interact with the hardware. Interact with the hardware is interact with the hardware means with the end hardware, whatever you're having, the server hardware. So whenever I want to interact with the hardware, you can interact with the hardware with the help of an operating system itself. Like for example, I'm sitting here, I want to type some key from the keyboard. Okay, I want to do some operation through parallel port, serial port. There is a USB drive is there, USB port is there. I will plug in it. You're doing so many operations right in every day, right? You're using some hardware right every day in your day-to-day activity, right? Who is driving that hardware? Who is actually communicating the hardware? All communication happening with the help of an operating system itself. So whenever the end user he want to interact or he want to communicate with the hardware, like this is hardware, he can, guys, this end user can only interact with the hardware when there is an operating system. So for example, this is the Windows operating system or Linux operating system. Anything it could be Linux or it could be Windows, anything. So you have an operating system. So Linux or Windows OS. So end user, whenever the end user, he want to communicate with the hardware, or you want to communicate with a machine or a system or a server, he cannot directly communicate it. There has to be an interface, and that interface is not, but it's an operating system called operating system. So here what happened, guys? This end user, he first sends a request to the operating system, and from the operating system, a request will be sent to the hardware. This is how the communication happens. So what happened, guys? What the Linux OS will do, or any OS will do, any kind of an OS, it could be Linux or it could be, it's a Linux OS or Windows OS. It is a interface between user and hardware. You have to say like this. This is a very, very simple definition. Suppose somebody asks, what is an operating system? So operating system is an interface between the user and the hardware. That's all. So Linux operating system is a set of program or models, okay, with which the communication happens between user to the hardware. It's a set of program, it's a system files we say, or set of program. So which controls and coordinate the hardwares actually, which controls and coordinate the hardware, or or that's what it's a communication happens between. So Linux OS controls and coordinates the hardware resources. Simple term. Am I clear on this, sir? Till here?
Yes.
Okay, good. So without the operating system, Rajesh, can an end user can communicate the hardware? Yes, there are some scenarios are there, not everything. Like not every time that the end user can communicate the hardware without OS. Yeah, there are one or two scenarios are there, right? That are exceptional cases, but 99% of the time, always a user can interact with the hardware or he can communicate with the system with the help of an operating system itself. Without the operating system, a user cannot communicate with the hardware at all. Now, what is this OS is all about? Rajesh, what is this OS is all about? So guys, OS basically, what is OS? OS, sorry, operating system consists of 6 major components. So what is operating system is made up of? Okay. What OS means, what is the OS made of? So guys, the OS basically, guys, the OS is made of 6 major components. What are those major components in case of file system, memory management? Some of you already know this memory management, file management. The file manager I already written, network management, or else before network management, let me write a process management. Okay, file management, file system management, we say. Memory management, process management, network management, uh, and device management. Not six, five actually, device management. So there are basically the OS contain majorly 5 components, not 6, sorry. Okay, so it means that Rajesh is the operating system is mixture of all these components. Yes, sir. Even Windows, even Mac. Yes, sir. You take any operating system, every operating system is consists of all these components. File system component, file system manager component, memory management, device management, network management, process management. Right? These are all the different components of operating system. Right? And basically, guys, whenever you take the any operating system, like for example, you take a Unix operating system or a Linux operating system or a SCO Unix, there are different flavors are there, right? All these operating systems are written in C language. Alright, whereas a Windows, okay, Windows operating system, it is written by Microsoft's own language actually. Microsoft has built their own language. So using that language only the operating system is written. So we will not know the code at all. We'll never able to see that how Windows operating system code look like. But as a Linux, we can see it because Linux is an open source. It's freely available. It means that the entire code is freely available. So where I can found all those code actually. Guys, what Linus Torvalds did that once he released the Linux operating system under the Free Software Foundation, which we discussed, what Linus Torvalds did that, Linus Torvalds, the guy, Linus Torvalds, he started his own organization, he started his own company, which he called it as a not organization, he opened a website actually, which we call as a w.kernel.org. So here what happened, all Linux version, all Linux uh, OS versions are uh, are released in kernel.org site actually. So whenever I want to download any latest kernel, I can go it. See, if you go to the net and if you go here and if you click on, sorry, if you type a kernel.org, type it here like this, guys. Can you see here the latest version, what is available? 6.17.1. So 6.17.1 is a latest kernel version or operating system version of Linux. Linux latest version. Am I clear on this, sir? Sometime they might ask you, okay, in which version you have worked on it. So you'll say Linux 5 point version, sir, 5.4, 5.6, 5.8 version I have used like that. They'll ask you. Okay, what about 6 version? Have you used it? No, sir, I have not used the 6 version because in our project we have not used that version at all till now. We are not upgraded to that version, we'll say like that. So of course, obviously, what happened when you work on newer versions of operating system, you'll get a lot of new features also, right? So like that actually. But it doesn't really harm you if you're working on 4 dot series version or 5 dot series version. It doesn't really harm you. You can still work on system because you might have not upgraded to the latest version. That's okay. But what happened, right? Whichever version you work on it, you should be comfortable in working on Linux because Linux is 90% is what commands. If we every day we execute the command and if we learn everything, it becomes very simple actually. Am I clear, sir? So guys, what I will do, I will not continue further here. I will stop it here itself. I hope that something, okay, we just started now, but what we're going to do in today evening. So guys, I'll be taking one more class today evening. Is it fine for all of you?
Yes, Rajesh.
Yes,
Uh,
Rajesh.
no, everyone have to say yes. If if some of you say no, sir, I mean it's not required, means I will not take actually. I don't want to really force. But if
Yes,
I
sir. Yes.
ask, if I request that please come, means okay. Now what's the Indian timing which you would like to come? For me, there's no problem. For me, there is no issue. Is it fine for you all 6 o'clock evening today? What's the time now in India? It is 12:17. Another after 5.5 hours, 6 to 7:30 or 6 to 8. Give me 2 hours of time. I will cover. We'll start digging more into Linux now. Because I have to start from here onwards, like operating system. Few background I have to explain about file system, memory management. I'll show you some diagrams and all. I'll explain and show in the diagram how this operating system look like, what is user space, what is kernel space. So many small topics I have to cover, guys, so that we will be in comfortable place where we will be in comfortable position, sorry, where we will be able to understand in a deeper way how this operating system works. And finally, what happened? We will be showing you some lab exercises. Yeah. So fine, sir. Naveen, everyone, Ganesh, राजीव भाई, पंकज भाई, ठीक चलेगा? अब इनके लिए 6 बोल तो हमारे लिए 9:30 है भाई, 7, 8, 9, 9:30 रहेगा हमारा रात का. ओके ओके, थैंक यू पंकज. राजीव भाई,
Yes, sir, fine.
9:30 अभी हमारा, देखो हमारा टाइम अभी है, यहाँ पर है हमारा. इट्स टाइम हियर इज 4:50, राइट? नॉट सॉरी, 3:50, राइट? फॉर अस इट इज 3:50. सो व्हेन वी टेक द क्लास, आई थिंक इट विल बी अराउंड 9:30 फॉर अस. तो हमारे पास
Yes,
और
sir.
5 साढ़े 5 घंटा है हमारे पास. वी कैन टेक रेस्ट.
Yes, sir, that is fine for me.
Yeah, sure, sure. Thank you. Yeah, 6 p.m. is okay. Thank you, guys. Then it's Sunday. Anytime is okay with me. Okay, thank you, Pankaj. So, guys, let me stop the recording. I will give this recording in some time for you all. And guys, how I'm going to give this? Let me create a drive, and I'll put all those videos, everything in the drive, and I'll share the drive to you all so that you can go and download those videos actually. Right? Notes will be given. All this class notes plus PDFs and all will be given. Don't worry about the PDF notes and all. I will take care of that from my end. You please concentrate only on learning the things. Okay. And also make your own notes. You can follow any of the notes, your note, my notes, or your own notes. It's immaterial, but you have to have your own notes. You should understand very well the concept. Is it fine? Okay, guys, with that, let me stop the recording then.